So now let us take another example. So here the numbering is starting from the bridge head 1, 2, 3, 4, 5, 6. So the numbering is given to the anti-clockwise direction and 7 and number 7 and 8 to the bridge, and the double bond is present in 2 and 3. So here 1 and 4 are the bridge heads. So next we have to give the numbering in another way, give the numbering in another direction, that is clockwise direction. So we can write it as 1, 2, 3, 4, 5 and 6 in the clockwise direction. So here also the bridge heads are 1 and 4, 7 and 8 to the bridge, and the double bond lies between 6 and 5. So from these two structures, which one numbering is correct? So here the second one is wrong and the first one is correct. Why? So as we know by the IUPAC rule, the least numbering is given to the double bond. So the second numbering is not correct because the double bond lies in between 6 and 5, carbon 6 and 5. So the first one is correct. So the name is octuene, because here the total number of carbon atom is 8, so octane, and one double bond lies in between carbon 2 and 3, so the name of this compound is octuene. So then we can count the number of carbon atom present in one side of the bridge. So here the total number of carbon atom present on the left side of the bridge, that is totally 2 carbon atom, carbon 2 and carbon 3. And the total number of carbon atom present on the right side of the bridge, that is carbon 6 and carbon 5. So there are also 2 carbon atoms present. And 7 and 8. So these are the carbon atom present on the bridge. So the name is, it is a bicyclic ring. So bicyclo. Then there are 2 carbon atom present on the left side of the bridge. So 2, and there are 2 carbon atom present on the right side of the bridge. Again 2, and there are 2 carbon atom present on the bridge. So again 2. So we can write it as bicyclo bracket 2 dot 2 dot 2 octuene. Okay. So then we have to move on another example. So let us start the numbering 1 to the bridge head. So we can give the numbering starting from the bridge head 1, 2, 3, 4, 5, 6. So here the nitrogen is numbered as 4 and 7 and 8 to the carbon atom present in the bridge head. So here 1 and 4 are the bridge heads, but actually this one is wrong. So why this one is wrong? So here the bridge head which start with the nitrogen. So nitrogen is a heteroatom. So you should start the numbering from the nitrogen. So the second one is correct. So we can start the numbering from nitrogen 1, 2, 3, 4, 5, 6 and to the bridges 7 and 8. So here also the total number of carbon atom is 8. So we can write it as octane. So it is a bicyclic compound with nitrogen. So we can write it as 1-asa bicyclo. The suffix of nitrogen is asa. Here nitrogen is present in the first position. So we can write it as 1-asa bicyclooctane. So next we have to find out the total number of carbon atom present on each side of the bridge. So here the total number of carbon atom present on the left side, right side and on the bridges are 2, 2 and 2, because on the left side 5 and 6, total number of carbon atom present on the left side 5 and 6, so there are 2 carbon atom, and on the right side 3 and 2, so there is also 2 carbon atom, and on the bridges 2 carbons, because 7 and 8, so there is also 2 carbons are present. So we can write it as 1-asa bicyclo 2.2.2 octane. Thank you.